Hi there, I'm Nix, and today's video is all about solving the reverse linked list problem on the LeetCode website. As always, I will give you all the details of the entire process, through the planning of the algorithm, to the coding of it, to the analysis of time and space complexities, as well as looking at LeetCode rankings. If that sounds interesting to you, then stay tuned. Welcome back, and let's get started. This problem gives us the head of a singly linked list, and as the title indicates, we want to reverse that list and return that reversed list. And then we're given an example here to drive home the point, with the list initially going from 1 to 2 to 3 to 4 to 5, and we want to reverse that such that we start at 5 and go to 4 to 3 to 2 to 1, and so on and so forth. Constraints here, where it can be given anything from, as in example 3, an empty list to one with a fair amount of nodes in it, and those node values can be anything within this range. Finally, there's a follow-up question that says it can be solved either iteratively or recursively, and can you implement both? This video I'm going to do the iterative approach, and then once I get into the recursion problems, then I will come back to this problem and show you the recursive solution for it. With all of that said, how do we do this? Well, the gist of it is we're going to have to loop through the list and update pointers as we go. But we need to be careful while doing that, because we don't want to get into a situation like this, where, say, we're at node 2 here, we reverse its pointer, so instead of pointing to the 3 node, we reverse it and have it point to the previous node, the 1 node. But without updating everything else, we can see an issue here. We now don't have any pointers pointing to that 3rd node, and thus we don't have any way of going through the remainder of the list, which presents an obvious problem. So we need to update these pointers in such a way that we never get into that situation. So that begs the question, what variables do we have to create in order to record necessary information so that this situation never happens, and we can update the pointers without ever breaking our links to all of the nodes of the list? Well, since we want to reverse pointers, we know we have to have one variable. We need to have a linked list pointer that will point to the node that we want to update, essentially to where we want to reassign its pointers. So that's one variable. Now we also, in addition to that node, we have to keep track of the node that comes right before it, because that's the node that we want the new next pointer to point to. So we're going to need another linked list pointer that points to that previous node relative to the one that we're working on. And with these two variables, we can now successfully walk through this list and update the pointers. Now before we get into the code, I want to point out that the head node here, 1 in the case of example 1, is a bit of a special case. At the end of the loop, the 1 is going to be the tail of the list, and its next pointer is going to point to that null signal. And as a result, the head node is a really good one to use to update its pointer every time to point to the next pointer in the list as we go through the loop, so that by the end of the loop, it will be pointing to that null signal. So let's do a brief mental walkthrough of the steps that we need to do, that we need to translate to code in order to solve this problem. With the head being the first one in the list, there's no previous node to look back on. So our first assignments are going to be the 2 node is going to be our update node, and our head node is going to be the previous node. With those assignments recorded, we are now free to update some pointers. Now, as the previous example shows, we can't really update the 2 nodes pointer immediately. Before we do that, we need to have another pointer pointing to 3 first. But we can do that with the head node here. Because we have the 2 node recorded via our update node variable, we have a reference to it. So that frees up the head pointers to point to 3. Now that we have that link to the rest of the list, that frees up 2's pointer to be reassigned from pointing to 3 to pointing back at the previous node, which in this case is the head. Now that we've reassigned that next pointer, we can now update our update node and our previous node to shift them up 1. So update node will now be 3, and previous node will now be 2, and then we can go through the entire process again. And by the time we loop through the entire list, we have completely reversed list, and we know when to stop when the head node pointer is pointed to the null signal. So with that battle plan as to the steps that we need to accomplish, let's go ahead and start the coding process. First up are the creation of the variables here. We have a list node pointer called previous node, and I've assigned it initially to the head. And we have another list node pointer, which I called node to reverse, and I assign it to head next. Next up is the while loop. And again, we know our exit condition. Once head next pointer is null, we have gone through the entire list. So as long as that is not true, i.e. head next is not equal to null, we continue on in our while loop. And here is where we're going to accomplish those 4 steps that I explained in the planning process. First up, we reroute head next to point to whatever node to reverse is pointing to. So head next is going to be equal to node to reverse next. Next up, we can reverse the pointer for our node to reverse. So node to reverse next can now be freed up to point to previous node. With the reversal complete, previous node can now be updated to what node to reverse is currently set to. And now that frees up node to reverse to be reassigned to whatever head next is pointing to, the next node down the list. Final bit of code to do is at the end of this while loop, the previous node is going to be pointing to the new head of the list. So we make sure to reassign the head of the list to previous node and then return said head. Now this code is mostly complete. What I mean by mostly complete is we can run the code to test that initial example here, and you see it works fine. However, there is a flaw in this code. It fails to take into account a particular edge case. And can you see what that edge case is? I'll give you a hint. This edge case is one of the examples that was given to us here. Yep. That's right. What happens when we're given an empty list? Well, I'm assuming here with these assignments that there is a previous node, which is a head, and a node to reverse, which is a head next. But if I'm given a list that is empty, then I'm going to run into problems, as we can see with the custom test case here. If I'm given an empty list here and I run things, what's going to happen? Yep, a runtime error. Because in this case, the head is null and there is no head next. But that's a really easy thing to solve, which is done via a simple if check. Before I do these assignments, I'm going to check if I'm given an empty or a one item list first. Because if I'm given a one item list, well, I don't have to do any of these things. I can just simply return the head. So if head is equal to null, or if head next is equal to null, I simply return the head. I don't need to do anything more complicated than that. Now, when I click run, I'm not going to get that error. No nasty red text. And finally, when this is finished, you can see it handles it perfectly well. So now the code is complete, and we are free to click a blue button and see if I've messed anything up. Which I haven't, which is always nice to see. All right, before we click the more details button, let's do a brief analysis of the time and space complexity for this one, which is fairly easy. We only have pointers as our variables, thus they take up constant space, and for space complexity, we have a big O of 1, constant space. For time complexity, we only have one loop here, which is doing constant time work, so the amount of instructions it needs to execute is directly proportional to how big the list is. And thus, it's going to have a big O of n, where n is the size of the list, time complexity, or linear. With that out of the way, we can then click to see rankings, which again, take with a grain of salt as it tends to ping pong around. So I'm here, I've seen it also crop up around here as well, and I'm sure it can go down to the lower areas as well, so. But nice and basically middle of the road in terms of graphs for this solution. Alright, that was how to solve reverse linked list iteratively. I hope this video helped you out. If it did, consider subscribing. And as always, I will wish you happy coding and to have a nice day.